So two particles are at rest initially and they are infinitely separated. If they start moving under the action of mutual gravitational attraction, what is their relative velocity when they are at a distance r from each other? We know that the range of the gravitational force is infinity. Suppose m1 and m2 are two masses which are originally infinitely separated. But because of the gravitational attraction, because the range is infinity as I said, so they start moving. So suppose m1 has come here and m2 has come here under the action of mutual gravitational attraction, and the distance between them right now is r. So m1 has acceleration in this direction and m2, let's say its acceleration is a2, and that will be in the opposite direction. So this is m1 and this is m2. The force is mutual. That means force exerted by 1 on 2 or 2 on 1, both are same. We know that force is equal to g into m1 m2 by the distance square. So at this instant where we would like to find the acceleration, the distance is r, so that the force is g m1 m2 by r square. So the same force is acting on each. We know that force is equal to mass into acceleration. Force on the first particle is m1 into a1. Force on the second particle is m2 into a2, but the left hand sides remain the same. Then this force is g m1 m2 by r square, that is equal to m1 a1, and g m1 m2 by r square is equal to m2 a2. This thing is a1 equal to g m2 by r square and a2 equal to g m1 by r square magnitude wise. But this is in the opposite direction. A2 is in the opposite direction. If you consider a1 as positive, a2 is negative, because acceleration is a vector, so the direction matters. So a2 is, let's say, negative. Then what is the relative acceleration of 1 with respect to 2? You can find anything, acceleration of 1 with respect to 2 or 2 with respect to 1, because we are supposed to find only the relative velocity. For that we are going to find out relative acceleration. So that is equal to g a12 is actually a1 minus a2. So a1 minus a2. a1 is g m2 by r square minus a2 is minus of g m1 by r square. So that is equal to g, minus into minus plus, so g by r square into m1 plus m2. So that is acceleration, simply a relative. I'm going to call acceleration of 1 with respect to 2 or 2 with respect to 1 as simply a equal to g into m1 plus m2 by r square. So we are supposed to find out velocity, so we are going to use chain rule. A equal to dv by dt. Here distance dependent equation is there, so we are going to convert this into distance dependent equation by multiplying and dividing by dr. So what you will be getting, dv by dr into dr by dt. Dr by dt is velocity, so the acceleration is actually v into dv by dr. Suppose if you have with respect to x, you will be having dv by dx and so on. So a can be written as v dv by dr equal to g into m1 plus m2 by r square. So here v dv equal to g into m1 plus m2 by r square into dr. So when you integrate it, at originally when r is equal to infinity, the velocity is 0. By the time r becomes r is equal to r, the velocity, let us assume v. Since it is a, the relative acceleration, what you will be getting here is relative velocity. So v dv is v square by 2, upper limit is v, lower limit 0. So there is other method to solve this. Anyway, we'll first solve using this. G into m1 plus m2 into r dr can be written as, this step could be written as g into m1 plus m2 into integral r power minus 2 dr. So that is when you integrate this, what you will be getting, r power minus 2 plus 1 by minus 2 plus 1, which is r power minus 1 by minus 1, which is minus 1 by r. So that we are substituting here. So infinity to r. So here upper limit minus lower limit is v square by 2 minus 0 equal to g into m1 plus m2 into upper limit minus 1 by r minus of minus 1 by infinity. This term gets 0. So v square by 2 equal to minus of g into m1 plus m2 by r. So this energy has been converted into kinetic energy. What we are looking at is only the magnitude. So we could have added the negative sign there. It's not a problem, because the thing why I have converted this negative into negative as positive is because they mutually attract each other. By when r decreases, speed increases. So usually they are inversely proportional, opposite. So that is the reason why we can convert the negative into positive. So v square equal to 2 into g into m1 plus m2 by r, or the relative velocity of approach is root over 2g into m1 plus m2 by r. There is another way of doing this that we will be discussing in the next video.